Double trouble. How to not explain a text classifier's decisions using counterfactuals synthesized by mass language models. Work done by Thang Phạm, Trung Bùi, Long Mai, and Anh Nguyễn. When we fit a sentence, the film's performances are thrilling to a black box text classifier, it says. This is a positive review. But how did each word contribute to this machine's prediction? Leave one out is a well-known method for estimating the attribution of each token to the classifier's output by removing one word at a time, for example, thrilling, and computing the prediction difference between before and after the removal. Repeating the process for every other token results in a leave one out attribution map. Wait a sec. Let's look closely. These counterfactual sentences are actually broken English or out of distribution to the text classifier, which may yield inaccurate attribution maps that are not aligned with humans. To combat this problem, two research teams propose input marginalization or IM method. Instead of deleting a word, IM used bird to replace here thrilling by other plausible words such as poor or excellent. The sentences are now syntactically complete and may have new predictions after fed again into the classifier. IM computes the weighted average of the word likelihood and classification prediction over the top k highest likelihood words V. As seen leave one out, IM takes the prediction difference as the importance score. Here thrilling and performances are the two most important tokens. IM was reported to be superior than leave one out by multiple papers, yet they were quantitatively tested on only one metric and one dataset. Furthermore, we find that removing a single token often marginally changes the confidence scores, questioning the need for bird completed sentences. What are the merits of input marginalization? To understand that, we rigorously compare leave one out and IM on 3 different datasets using 2 bird-based backbones and 6 evaluation metrics, starting from deletion, which is a traditional way to evaluate an attribution map by removing the highest attribution tokens one at a time and measure the drop in confidence score. Here, thrilling has the highest attribution and will be removed first. The modified sentence is then fed to the model to obtain a new confidence score. Repeat the procedure for film and then performances until all tokens are deleted. A better attribution method is expected to yield a smaller area under the confidence curve or the deletion score. To avoid the out-of-distribution issues in deletion, Kim and colleagues only evaluated IM on deletion bird, which replaced words instead of deleting them. Interestingly, we find that IM is the best under deletion bird, while leave one out is the worst. In contrast, under deletion, IM is the worst while leave one out is the best. That is, deletion favors leave one out while deletion bird favors IM. We also observe the same conclusion for other datasets and models. On the common raw and raw bird benchmarks, leave one out tends to outperform IM, but the gaps are smaller. Compared to human annotations of important words, here the yellow highlighted, we find that IM important tokens have lower intersection over union or IOU, precision and recall. In contrast, leave one out highlights overlap more with human highlights. This trend holds for 3 datasets. So far, IM is consistently not better than leave one out, but why? We find a theoretical flaw of IM in explaining a classifier's decision at the word level. For instance, in this AACL example, a group of people prepare hot air balloons for takeoff. A group of people prepare cars for racing. Human annotations show that hot air balloons and cars are the keywords for why the two sentences contradict. But IM heat maps show near zero importance scores for hot air and balloons, for another model and another. IM attribution scores of hot air and balloons are always near zero regardless of the target classifier that we try to explain. The reason is that those words are highly predictable from the context. For example, hot here is 99% likely to precede air and balloons in this context. Same for air and balloons. This makes IM attribution scores of hot air and balloons always near zero regardless of the target classifier that we try to explain. Are there still merits to use bird to replace words in future attribution methods? Take our original example sentence. When a single token is randomly removed, the average drop-in accuracy for three tasks SST, ESNLI, and multi-RC are marginal, and therefore we did not see any advantage of using BERT in IM to replace words. Yet, when many tokens are randomly removed in LAM method, the sentences are more syntactically broken. The drop-in classification accuracy therefore becomes significant. In this case, we find that integrating BERT into LAM to create natural counterfactuals improves LAM accuracy. In sum, we find that there exists a bias in deletion-related metrics when evaluating future important heat maps. We find no evidence that IM is better than the simple leave one out, but integrating BERT into LAM does improve explanation accuracy. Most importantly, IM generates fundamentally flawed explanations when the language model disagrees with the target classifier on which words are important. This research was funded by National Science Foundation, Auburn University, and Adobe Research.